Hey guys, let's discuss new problem from graph which is called Prim's algorithm to find the minimum spanning tree. To find the minimum spanning tree, we use two algorithms, which is Prim's algorithm and Kruskal algorithm. So here we will be discussing Prim's algorithm, okay? And in the earlier video, I have explained what is minimum spanning tree. And so let's say you have given this ages, okay? And let's draw graph according to these ages. So first one is 0, 1, okay? Well, the weight is 2. Second is 0, 2. The weight is 1. Next is 1, 2. The weight is 1. Next, after that 1, 3, this is 3, weight is 1, and 2, 3, this is, the weight is 2, okay? Now you need to find the minimum spanning tree. What it would be? 0, 1, 2, 3. See, I'll take the minimum ages, okay? So first this is 1, 0 to 2. Then 1 to 3, okay? And then 1 to 2. So the value, minimum spanning tree value will be 3, okay? So this is the answer. Now let's check what is how we can solve it using Prim's algorithm. So before that, let me shift it a little bit down, okay? Here. So this is my graph, and what you will take, just two things. One is visited array, okay, so that you will keep track of each vertices, whether it is done or not. 0, 1, 0, 1, 2, 3, 0, 1, 2, and then this is 3, okay, and then one priority queue, PQ, okay. Priority queue, we are storing weight and node, and on the basis of weight, it will return you the value, minimum weight, it will return you, okay. First, now initially, let's add 0, 0, which is 0 is the weight and 0 is the node, okay. This one is weight, this one is node. So now you need to run this process until your queue is not empty, okay. So first you will check, you will take out this 0, 0, and two things here. See, let's check the code also quickly, okay. What is happening? So your pair structure is something like this: weight, node, and this pair you will store in the PQ, okay, priority queue. Now you have given, you would be given vertices and then adjacent list, okay, adjacency list, and then priority queue you have created, and this is the lambda expression, okay. So on the basis of weight, it will return you the value, minimum value. You have created visited array, you have added 0, 0 into the node queue, okay, and sum equal to 0. You take one counter variable sum, not counter, one variable sum, where you will store all the sum, like 3 is the answer, right? So how you will get that? So from here, and then you will run this while loop until your queue is not empty. So till here we discussed, okay. Now first you will take the value from priority queue, and let's say it as pair P, okay. You will extract weight and node from it. Let's say it WT and node, okay. Now here you will check, this is the thing, here you will check when you're taking value from queue, that time you're checking in visited array whether this node is visited or not. If it is already visited, you don't need to process it, okay, and just simply continue. Otherwise, just mark it as true. So first we have taken 0, 0, that is not visited, so I have marked 0 to true, okay. Now sum equal to sum plus weight, so whatever weight it has, you just add that into the sum variable, okay. After that, you traverse all its adjacent neighbors. So who all are? Neighbor of 0, it is 1 and 2, 1, 2, these two neighbors, okay, and check it's a weight. If it is not visited, then only add that into the PQ. So first time you're checking for node which you are taking from priority queue, and second time you're checking for the adjacent neighbor before adding it to the priority queue, okay. So two times, when you're taking value from priority queue, when second time when you're adding value from the priority queue. So now its a neighbor is 0's neighbor is 1. So to reach the 1, how much distance it will take? 2, right? So I will add 2, 1. 1 is the node, right? And then second is 2, right? So I will add 1, 2, where 1 is the weight and 2 is the neighbor. Okay, this is done. Now I will take out another value from priority queue. So this time this will be this 1, 2, because this is minimum priority queue, right? So it will give me minimum distance priority queue. It will give me minimum distance pair first. So 1, 2 came, where 2 is the node and 1 is the weight. So let me add this weight into the sum. Now to check all the neighbors for 2, but before that, just check if it is not visited. Yes, it is not visited, so mark it to true. And all the neighbors of 2, who all are neighbors of 2? 0, 1, and 3. Okay, 0, 1, and 3. But you can see that 0 is already visited, so no need to process it. So I'll remove 0 from here list. Now 1, 3. So who all are? So to reach from 2 to 1, what is the distance? 2 to 1, it is 1, right? So I will add this value 1, 1. Okay. So to reach till the node 1, it will require one distance. So 1 is done. Now let's check for 3. It is 2 distance, right? So 2, 3 I will add into the queue. This is also done. Okay, let me remove this. Now let's take another value from priority queue. What it would be this time? This 1, 1, because 1 is the minimum distance, right? So I will add this 1 into the sum, and then who all are distant neighbor of 1. So first I will mark it as true. If it is not true, then once all neighbor, who all are those neighbors? 0, 2, and 3. 0, 2, and 3. But you can see 0 is already visited, no need to process it. 2 is already visited, no need to process it. Okay, it's time for 3. So for 3, to reach from 1 to 3, what is the distance? 1 to 3, the distance is 1. Okay, so I will add 1, 3. right? Now I'll take again new value from priority queue, and that this time it would be 1,3, right? So I will add this weight here in the sum, and then I will check all the neighbors of 3. So all the neighbors of 3, who all are neighbors of 3? 2 and 1, 2 comma 1. But you can see 2 is all, and by the way, I'll mark it to 2. Okay, this time I have taken 3, right? So now if I check 2 is already visited, I'll not process for 2. 1 is already visited, I'll not process for 1. Okay, let's take another pair from but whatever you will take, actually the visited array is completed, right? So you will not process for anything. So this will be your final answer. Your final answer is 1 2 3. So that is your answer. Okay, and this is the code. We have already discussed the code. So that's it. Thank you.